Okay, here we are doing solving linear systems. Now if you have your review sheets with you, it might be handy to get that one out so you can refer to it. I don't seem to know what I did with mine. So substitution means we're going to replace an expression with a letter. So I'm going to look at this. In this case, I have these both equal y equals x minus 5, y equals 3x minus 3. So essentially what I'm going to say is y is equal to y. I know that seems weird, but I've got two equations that says y equal to y. That y is equal to all this and y is equal to all this. The whole point is I need to just have one letter so I can solve for that letter. But in each of these I have two. So I'm going to start with this idea of y equal to y. I'll write it down again here. And so I'm going to write, instead of y, I'm going to write these two things. So instead of this first y, I'm going to write x minus 5. And then I'm going to put equals. That's my first y. My second y is this one, 3x minus 13. So instead of writing y, I'm writing x minus 5 right there. Instead of writing this y, I write 3x minus 13. Now when I look at this expression, I have only x's. So what I need to do is I need to go ahead and isolate or solve for x. This is where I choose what to multiply or divide to get it by itself. So I know most people like to have the variable on this side, so I'm going to think, all right, I'm going to subtract 3x, because if I subtract 3x on this side, I need to subtract 3x on this side. It doesn't really matter where I put it, but I usually put it under the like term. The reason I chose it is so this became 0. And here, if you've forgotten, if there's an x, it's like there's a 1. So yes, there's no x's on your calculator, but you're always doing just the math with the numbers out in front, the coefficients. So it's 1 minus 3, that equals negative 2, and you can't forget to write down the x. The minus 5, I didn't do anything with it. This term went to 0, or became 0, and so I'm left with minus 13. So now what I want to do is, I again need to get x by itself. So I'm going to choose to get rid of this term right here, the negative 5. The opposite of negative 5, or subtract 5, is positive 5. But whatever I do on one side, I must do on the other. All right? Notice I don't put the line underneath because I'm not dividing. I'm adding or subtracting. In this case, I'm adding. So negative 5, or minus 5 plus 5, ends up being 0. If you're not sure, go ahead and do it in your calculator. This is the one thing I wanted to show you before, though. This, you have to use this sign up here to indicate a negative 5. It's not the same as using a minus here. So plus 5, and that equals 0. So the whole term is 0. So over here, I'm left with a negative 2x. And on this side, go ahead and do that. Negative 13 plus 5. That gives you negative 8. Now I need to get rid of the coefficient, the number in front of x, that is multiplying by it. The opposite of multiplying is division. Whatever I divide on one side, I must divide on the other. I want this to become 1. So to become 1, I need to divide by a negative value, because a negative divided by a negative is a positive, and I want to divide by negative 2, because that will give me a value of 1. So I'm left with x. You have to do this on your calculator. Now, the one thing I do is, I see two negatives, I know the answer is going to be positive. I don't bother putting that in my calculator. I just do 8 divided by 2 and I get 4. But I will show you here, if you put negative 8 divided by negative 4, let's see, fix up those two signs beside each other. It does, and it's, oops, what did I do that? Oh, I was supposed to divide by negative 2. Negative 8 divided by negative 2. I just didn't understand why I got a different answer. Now that's only half of our point, because when we're solving for a linear system, and I should have said that solving for a linear system, when we're finding the point of intersection, the POI. So that's only half of it. Now I have to solve for y. So now to solve for y, I take one of the equations. I'm going to choose this one. See how there's less numbers involved. Y is equal to x minus 5. So I'm going to put in for x here is 4, because that's what I found out, and I get what y is equal to. 4 minus 5 is negative 1. So therefore, the point of intersection, we should make sure we do this right, the x is the 4, the y is the negative 1. Now, I'm not going to go ahead and check this one, but I'm going to do a left side, right side check on this equation. The left side is equal to y, and that's equal to negative 1. My right side of the equation is 3x minus 13. So I'm going to sub in for x. That's 4 minus 13. 3 times 4 is 12. Write down the minus 13. 12 minus 13 is negative 1. See, left side is negative 1, right side is negative 1. That's how I knew I did and got the right answer. So if you're in the exam, then you know you got it perfectly done. Now, that's substitution. I'm replacing a letter with an expression. For elimination, what we do is we line them up, and this is where you add all the terms up and below. So right here, this one is more useful to do by elimination because I can see right here these are exactly the same term, but there's a negative. I'm going to rewrite them on top of each other because these are different size font. And this is a 6x plus a 4y equals negative 10. So if I call this A and I call this B, what I want to do here is I want to add A plus B. So I'm going to draw a line across, and I want to add these two things. So I'm going to come over here to this sign because I want to add them. So negative 6x plus 6x actually gives me 0x. Over here I'm going to go 5y plus 4y. Well, 5 plus 4 is 9, and that has a y term. Now this is 1 plus negative 10. If you need to write it out, you can go ahead and write it out like that if you need to. That's fine. That one has a 0 in front of it, so we're not going to bother writing it because 0 times anything is 0. And here you go 1 minus 10. Let's finish that off. 1 minus 10 is negative 9. If you need to check that on your calculator, 1 minus 10, negative 9. And I'm looking at this, I need to get rid of the coefficient here, so I'm going to divide both sides. I'm going to divide both sides by 9 because 9 divided by 9 is 1. And I want to get y by itself, but let's finish off balancing the equation. Negative 9 divided by 9, well, it's a negative divided by a positive, which is going to be negative. 9 divided by 9 is 1. So now I'm left with, that's the one part of the point of intersection. Now we have to find x. So I just choose A or B. I'm going to choose B just because there's no negatives on this side. But it really doesn't matter. You should get the same answer no matter which equation that you use. So I'm going to sub in for y. So there it is, 6x, I write it down. 4, I'm subbing in for y, so the y is gone. I'm putting in the negative 1 instead. And the negative 10 I haven't touched. So let's simplify this. 4 times negative 1 is going to be negative 4. And now I need to isolate x, so I need to get rid of this term. The opposite of subtraction is addition. Whatever I do on one side, I must do on the other. The reason I chose this was to make it 0. So I'm left with the 6x on this side. If you need to do the math on your calculator, go ahead, negative 10 plus 4, and I'm left with negative 6. Again, I want to isolate x, so I need to get rid of the 6 in front, but I do that with division because that's 6 times x, and I do it on both sides. 6 divided by 6 is 1. Negative 6, let me show you, negative 6 divided by 6 is going to be negative 1 because it's a negative divided by a positive. And there, my point of intersection is x is negative 1, and y happens to be -1. Now I'm not going to bother doing a left side, right side check with B, but why don't I do a left side, right side check with A? So my left side is equal to -6x plus 5y. So -6, x is -1. I write down the 5, -1, squishing this in here. -6 times -1 is actually +6. 5 times -1 is going to be -5. Do the math, I'm left with just a +1. The right side, go ahead and look at my equation, it's 1. So left side equals right side, check. So I'm done. So we're done with linear systems. Maybe I'll stop there and I will start again with the quadratic review.